Good evening, Dragons. Welcome to the remainder of Lesson 4, A Trip to the Moon. In Lesson 4, we moved from proportions and double number lines to ratio tables. In the warm-up, we did a bunch of proportions together, which was one ratio equal to another ratio, and we solved for the unknown. Period 2 completed the I'm Your Density activity, and all the other periods completed activity 4.1. In activity 4.1, we took many notes about the given ratio and creating equivalent ratios by scaling down and scaling up. We also talked about how elements of the table could be brought down into proportions and show the exact same concept in a different format. Additionally, you could put that same information into a double number line and get there by scaling down as well. A new concept that was presented to us by the textbook was composing. Composing corresponding parts is when we took something we knew from the table, and put it together to create the unknown in the table. So if we knew 60 and 30, we could get 90, but then we needed the corresponding parts of 10 and 5 to get 15. Some of us worked on number 1, where we proved the equivalency of all the ratios. The numbers I have written represented 60 pounds on the Earth to 10 pounds on the Moon, 35, 90, and 15. If we were to simplify all of these ratios, you would find that they all equal 6, which means and proves that they're all equivalent ratios. We can also find a different way to get from 90 pounds to 15 pounds, which we showed, I think, on the front, but we could get from 30 pounds on Earth to 5 pounds on the Moon to 90 pounds on Earth compared to 15 pounds on the Moon by scaling up using our multiplicative relationship times 3. Then we went into further notes about Howard and Carla. Ultimately, they were both scaling up, but Howard's table shows how you are counting by multiples of 30, although they're not in order. And for the Earth, and then for the Moon, you're counting by multiples of 5, although they're also not in order. The weight of the Earth is counted on a different scale than the weight of the Moon. That's how double number lines work as well. Carla worked from a lower ratio and scaled up by 4. Howard worked from a bigger ratio and scaled up by 2. We talked about Mitsu, who also composed here, taking 30 and 90 to make 120, 5 and 15 to make 20, so taking parts to make a whole. Ralph, we discovered, was incorrect in his thinking because he tried to do additive by adding the same scale to both sides, which created a unequivalent situation here. Because 120 divided by 45 is not 6, but 90 divided by 15 is 6, and we know this one to be one of the correct ratios. Had he realized that the relationship between those on Earth was plus 30 and those on the Moon was only plus 5, he might have gotten there. We also talked about Mitsu using corresponding parts to further the table. We found a couple other strategies to find this equivalent ratio. Now we're going to move on to activity 4.2. The 6th grade pizza party is planned for tomorrow. Tracy is in the charge of ordering the pizzas for 450 students. The pizza parlor said 2 pizzas will serve 9 students. Tracy made a ratio table to help her determine how many pizzas to order for 450 students. Explain Tracy's strategy and determine the number of pizzas needed. 2 times what would get you 10? If you said times 5, you're correct. 9 times 5, got to be fair, equals 45. Now she goes from 45 to 450. What relationship does she use here? Times 10, which means you need times 10 here. Ultimately, to feed 450 students, you need how many pizzas? 100 pizzas. Good job. Let's keep moving. Complete the table to show the number of pizzas to order given the number of students. Explain your calculations. So we can all travel up and down this table in different ways. I'm just going to show you my thinking. But if you came up with the correct answer in your own unique way using the correct relationships, then that's fine by me. I feel like we just did this one. So this one is times 10 times 10, going to get 100. Now I'm looking at 135, which for me is not a commonly used number. I'm assuming that 45 can go into 135, so I'm going to play with that for just a minute. I think it would go in 3 times. Over here, I'm going to test it. Great. So 45 times 3 would get me 135. So I'm going to do 10 times 3 to get 30 pizzas there. 270. I don't see a relationship here so much as I do here. This one really stands out to me. I can get from 9 to 270 by multiplying by how much? And if you're not sure, look at this part first. Take this 0 off to see the relationship between the 9 and the 27. So 9 to 27 would be times 3, but it's 270, so it would be times 30. Going from the 2 to match the relationship, I'm going to go times 30. So that would be 60 pizzas. 225. I did not easily see a relationship from here to here, but I did see a relationship from here to here. Do you recognize it? 225 is half of 450. I'm going to swoop with that one. I'm trying to change color pen so you can see all my different marks. That one is divide by 2. Corresponding is 100 divided by 2, which would be 50 pizzas. 900. You could take this and double it to get 900. Times 2. Times 2. Let's see, that was 100 times 2, so that should be 200. 1350. Not the friendliest number to me, so I thought we should compose. I put 450 and 900 together to get 1350. Watch this. I'm adding the 450 and 900 to get 1350, which means I have to add the 100 and the 200 to get, what's the grand total? 300. Excellent work. I'm going to leave that table there for a moment so you can make sure you understand how I got to everything. That is a lot of markings for you. Use your table of values to answer each question. Explain your calculations. How many students will 12 pizzas feed? I could do 2 pizzas plus 10 pizzas to get how many students it'll feed. If 2 pizzas feed 9 students and 10 pizzas feed 45 students, 12 pizzas will feed 54 students. So there I added the corresponding parts. How many students will 20 pizzas feed? I'm on part B. I have 20 pizzas. I could just double this. So if I had 10 pizzas feed 45 students, and I have 20 pizzas, I could show a proportion where I scale up by doubling both the numbers. In that situation, I'm going to be able to feed 90 students. So that is called proportion to make your equivalent ratio. And then, how many students will 90 pizzas feed? 90 pizzas. I'm thinking we could have done 100 take away 10, but I want to put together 30 and 60. So if 30 pizzas feeds 135 students and 60 pizzas feed 270 students. If I add the corresponding parts, I'm going to get 90 pizzas feed 405 students. So add corresponding parts. Good. 4.3, parts and wholes and ratio tables. Remember, the school colors at Riverview Middle School are a shade of bluish green and white. The art teacher, Mr. Rafe, needs to mix different quantities of the green paint for several school projects. It takes 3 parts blue paint to 2 parts yellow paint to create the bluish green color. Carla needs 5 total pints of the bluish green paint, so she used 3 pints of blue paint and 2 pints of yellow paint. Mr. Rafe thought that the art students needed a table to help determine the correct amount of each color of paint for different projects, both large and small. Complete the table with the correct amounts. Explain your reasoning. I'm taking a look at this. Amount of bluish green paint needed, 5, which would be 2 of the yellow and 3 of the blue, which does match with the given information here. You've got to have 3 blue to 2 yellow. So that would be the total. This is like the whole. So it's part, whole. So far I feel like we are scaling up and down the table. I'm going to do the easy ones first because here I'm looking for the whole, which means adding these. So that should be 20 pints. Now here would be times 3, which makes me think all of these should be times 3. Let's see if that works out. That would be 6 and 9. 9 plus 6 is 15. That works out nicely. How do we get from 18? 3 to 18 is what relationship? Do you see? Besides the sun glaring on the paper? 3 times 6. So then we have to do 2 times 6, which is 12, and 5 times 6, which is 30. 3 to 1.5 is cut in half. That's divide by 2 is from this column to this column is divide by 2. 2 cut in half is 1. 5 cut in half is 2.5. Check your table. See if you can find the relationships. Examine Sally's answer. Explain what is wrong with her thinking. Poor Sally. Already wrong. Hasn't even gotten started. If I want 15 pints of bluish green paint, then I will need to add 10 to the original 5 total parts of bluish green to get 15. So I should add 10 to each of the other numbers, too, to get 12 pints of yellow and 13 pints of blue. So she's taking the original formula of 5 pints, 2 pints yellow, 3 pints blue. She wants to add 10 to get 15 pints, but then she wants to add 10 here and add 10 here. I think I see a pattern. What are you seeing? She's not creating equivalent ratios because she's saying she's going to get 12 pints of yellow and 13 pints of blue. None of this makes sense. She's using additive reasoning. That's not going to work out for her. Not equivalent ratio. It's not an equivalent ratio. That ain't going to work. Additionally, 12 plus 13 does not equal 15. She would end up with 25 pints if she went down the road she was traveling. Charlie said, the table is helpful, but it cannot list every amount we might need for every painting project. I think if we multiply 2/5 times the total amount of bluish-green paint we need, we can determine the amount of yellow paint needed. If we multiply 3/5 times the total amount of bluish-green paint we need, we can determine the amount of blue paint we need. What do you think about Charlie's method? Is he correct or incorrect? Explain your reasoning. So Charlie says if we multiply 2/5 times the total amount of bluish-green paint we need, we can determine the amount of yellow. The yellow is 2 yellow to 5 tolu. So yes, Charlie's correct there. And then Charlie says we can multiply 3/5 times the total amount to determine the blue. Well, it is 3 blue to 5 total. So he's right there too. Charlene said, I am thinking about this in a different way. The amount of blue paint is always 1.5 times as much as the amount of yellow paint. Is she correct in her thinking? If we always have 3 blue to 2 yellow, if I were to scale it down, we always have 1.5 times as much blue. If we try to get to 1.5 blue, that would be scaling down by 2. I'm trying to prove whether she's right. So I'd have to divide this by 2, which would get you 1 yellow, which would be the statement, the amount of blue paint is always 1.5 times as much as the amount of yellow paint. That's true, because 1 to 1.5. It's like a unit rate. We've talked briefly about relationships within. 1 times 1.5 would get you 1.5. 2 times 1.5 will get you 3. 2 times 1.5 will get you 3. So this is the relationship within. This is the relationship between. Clifford said, my thinking is related to Charlene's. The yellow paint is 2/3 of the blue paint. Is Clifford correct? The yellow paint is 2/3 of the blue paint. It's always 2 yellow to 3 blue. How can we prove he's right? Do you have any ideas? The yellow paint is 2/3 of the blue paint. Clifford is correct. The ratio of yellow paint to blue paint will always be 2 to 3. So the amount of yellow paint in the total mixture of bluish-green paint will be 2/3 the amount of blue paint in the total mixture. They're not saying that it's 2/3 of all the paint. It's saying it's 2/3 of the blue paint. So if there's 3 blues, 2/3 of that would be yellow, which would be 2. It's a tough concept there. How does Clifford's thinking relate to Charlene's thinking? Charlene is basing the amount of blue paint for the total mixture on the amount of yellow paint. Clifford is basing the amount of yellow paint for the total mixture on the amount of blue paint. Both Clifford and Charlene are interpreting the ratio correctly. Their relationship is similar. Clifford's comparing yellow to the blue. Charlene is comparing the blue to the yellow. If I were to compare it to the sentence I just wrote now, Charlene would be more like 3 blue is 1.5 of 2 yellow, because 3 is 1.5 times 2. So Clifford says 2 yellow is 2/3 of 3 blue, because 2 is 2/3 of 3. Charlene's thinking is 3 blue is 1.5 of 2 yellow, because 3 is 1.5 times 2. Both of those statements are true. Just one person's putting yellow before blue and vice versa. These last couple questions are really challenging. These type of questions will not be tested. The type of things you'll have to work on will be things like Talk the Talk, the lollipop recipe, which I'll show in another video, and also these ratio tables. These will be homework, so if you want to get ahead on these, now would be the time to do these. You're going to want to show your multiplicative relationships, and you're allowed to calculate those and show me that thinking with the arrows, aka swoopy swoops. Or you can compose and get the portions to add up to the bigger part. Thank you for watching this video tonight, and I'll see you tomorrow, Dragons.